Hello, this is Joseph Goliardi. I'm a senior industrial engineer taking ENGI 460. And for the lab one, I first had to install a couple of different softwares, two of which I already had, MATLAB and SassJump, and of course AutoMod. So AutoMod we got downloaded here. So definitely excited to get to use this software and see what it's capable of. And here's MATLAB. And here is SassJump Pro 14, which actually has 40 days left on its license. In addition to this, part of the first lab was to make a simulation of the arrival of a person at a tool room, similar to the example that was found in the book in chapter 1. So if we go over to my lab 1, you can see that I have number of mechanics equal to 20, just like how the book had it. The time between arrivals, I did a rand between from 1 to 10. The arrival time was set as the sum of all of the previous sum plus the next current. So it adds all of them together. It's cumulative. The length of the service time was a rand between from 1 to 6. The time service begins was actually the previous time service ends plus the tool crib attendant idle time. Then the time service ends is equivalent to the time service begins minus the length of the service time. The time in the system was actually the time or the length of the service time plus the mechanic waiting time, and the tool crib attendant idle time. I actually used a more complex equation for this, just an if statement in case it was negative. So the arrival time, the current arrival time minus the previous time service ends. If that was less than 0, I would put a 0. However, if this was greater than 0, I would let it be the positive value that it is, as you can see down here. And then the mechanic waiting time would be the time service ends previous minus the current arrival time. So they're almost inverses of each other. And if it was negative, you would put a 0. But if it was positive, you would put what the positive value was. So as you can see, that's how I populated this table. And down here I have my totals for the time and system, tool crib attendant idle time, and the mechanic waiting time. And I use these to calculate these equations. So the average time in the system is actually the total time in the system divided by the number of mechanics. The percent idle time was actually the total tool crib attendant idle time divided by the entire time, the time the service ends. The average waiting time per mechanic was the total of the mechanic waiting time divided by the number of mechanics. So in this case, it was 0.2 minutes. And then the fraction of mechanics having to wait was, I used an equation to count if they were greater than 0. It was the number of times they were waiting on the mechanic divided by 20. So that would mean that's the fraction of mechanics having to wait. And then lastly, the average waiting time for those who waited for mechanic waiting time was the total mechanic waiting time divided by the number of times they had to wait for mechanic. Thank you for watching. This was the lab 1 for my project.